Welcome to ThirdEye Labs, where we make the unseen seen. Today, vectors and coordinates. Before arrows, the grid, two number lines crossing at 0. That crossing is the origin. Every spot has a name. How far across, then how far up. 3 across, 2 up. The point 3, 2. Go left or down, and the numbers turn negative. Same rule, 4 directions. That is the whole coordinate plane. An arrow. Drop a line to each axis and read the numbers off. 3 across, 2 up. That pair is the vector. Move the arrow, and the numbers move with it. One object, two views, always in sync. Here is the trap. A vector is not a place, it is a movement. From here to here, 3 across, 2 up. Start that same movement anywhere on the plane. It is the very same vector. The location does not matter, only the change does. Same destination, two ways to say it. The list is the address. The arrow is the directions to get there. Add two vectors. Here is the first, 3 across, 2 up. Here is the second, 1 to the left, 2 up, also from the origin. To add them, slide the green arrow, keeping it parallel, until its tail sits on the cyan tip. It is the same arrow, just moved over. The sum runs from the start straight to the finish. And on the right, the columns just add. 3 minus 1 is 2, 2 plus 2 is 4. Same answer, two ways. Two sets of walking directions, back to back. Where you finish is the sum. V minus W. Here is the secret. Subtraction is just addition in disguise. V minus W is V plus the flip of W. So first, flip W. Spin it around to point the exact opposite way. That is minus W. Now add it the way you already know, tip to tail. Slide the flipped arrow so its tail sits on V's tip and walk it. Where you land is V minus W. The columns confirm it. 4 minus 1 is 3, 1 minus 3 is minus 2. And the picture to keep. That very same arrow is the trip from the tip of W to the tip of V. The difference points to the first one. Every movement has an opposite. Walk 3, 2. Then walk minus 3, minus 2. You land exactly where you started. Add them and you get the 0 vector, no movement at all. The one vector every space is built around. Scale a vector by a number. Drag it up. The arrow grows and the list grows with it. Shrink it and flip it negative. Same line, opposite direction. Scaling a vector is zooming a photo. Same picture, same direction, just bigger or smaller. How long is the arrow itself? It is the hypotenuse. So Pythagoras, 3 squared plus 2 squared square rooted, root 13 about 3.6. A vector's length is just a right triangle. Where does the grid even come from? 2 tiny steps. 1 step right I hat, 1 step up j hat. Lay 3 I hats end to end, then 2 j hats. That is the vector 3, 2. 3 I hat plus 2 j hat. Repeat those 2 steps everywhere and the whole grid appears. The grid is not the background. It is what those 2 arrows build. Here is the punchline of the grid. Every vector is just a recipe. So many I hats, so many j hats. Take minus 1, 4. That is 1 I hat to the left, then 4 j hats up. Follow the recipe and the vector appears. Change the 2 numbers, and you can build any vector at all. Every vector is a recipe of these 2 arrows. 1 step right, 1 step up. Repeat those 2 moves and you can reach every square on the board. In 2 dimensions, easy. An arrow, 2 numbers. 3 dimensions, still fine. Tilt and there it is, 3 numbers. 4, the picture gives up. But the list does not, just add a number. The math never needed the picture. One last leap. A house. Measure it, size, price, age. 3 numbers fly into a list, and a list is a vector. So this house is a single point, 1 axis for size, 1 for price, 1 for age. The 3 numbers place it in space. Add 2 more houses, and data becomes geometry. That is where season 1 begins. A house is a list, size, price, age. 3 numbers, so a point in 3 dimensions. That is all a data point is. Everything so far was the warm-up. Now, the part school skips. This is how AI actually compares meaning. The dot product, one number for how much 2 arrows point the same way. Here is the picture. Drop W straight down onto V. The thick piece that lands on V is its shadow. Now turn W and watch the shadow. Pointing the same way, a long shadow, a big positive number. Square on, the shadow vanishes and the number is exactly 0. Pointing back, the shadow flips and the number goes negative. The dot product is that shadow. In symbols, that shadow idea is this: the two lengths multiplied times the cosine of the angle between them. That is what the dot product means. But here is the gift. You never measure an angle. Just multiply the matching numbers and add. 3 times 2 plus 1 times 2 is 8. The very same answer, the easy way. Pushing a cart that only rolls forward. Push straight along, all your effort counts. Push sideways, none of it moves the cart. Push backward, you fight it. The dot product is exactly that, how much of one goes along the other. Turn words into vectors. King and queen point almost the same way, a tiny angle between them, about 11 degrees. Its cosine is near 1, very similar. Now banana, a wide angle over 80 degrees, so a low cosine. That number, the cosine similarity, is exactly how AI compares words, faces, and songs. It is just a dot product, normalized. People think vectors are physics arrows. Forget that. The arrow is just a list, and a list is just a row in a table. Any list of features, no arrow required, is a vector. In one breath, an arrow is a list of numbers, add by walking or by columns. Its length is Pythagoras. The dot product tells you how much two vectors agree, and that, normalized, is how AI measures similarity. Any list of features is a vector, so all of data is geometry. Next, a vector that can also turn. The complex plane, where multiplying is rotating. Thanks for watching and keep exploring. Next time, complex numbers. Please like and subscribe ThirdEye Labs if you enjoyed this video and let me know in the comments.